Hello, everybody. Welcome to section 6.2, parallelograms. So we've talked about degrees and angles, and now we're going to be very specific, and we're just talking about parallelograms. Notice it says we're going to recognize and apply rules of angles, sides, and diagonals. So we need to address those things. So first of all, let's talk about the rules of a parallelogram. So sometimes I get a little lazy and I use the parallel sign with a gram after it, because who wants to write that all out? So here's our first rule of a parallelogram. The opposite sides of a parallelogram are congruent. Opposite sides are congruent. So in this example up at the top, notice I've got PQRS. Notice that PQ and SR are parallel to each other. Notice that PS and QR are parallel to each other. I've got those single and double parallel marks. So in the second column over here, we're going to fill in what applies from that particular example. Notice up here at the top, I'm saying if this is a parallelogram, I'm saying in the directions. Hey, by the way, PQRS is a parallelogram. If we're going to apply this rule that opposite sides are congruent, we're going to be able to say that PQ is congruent to SR. And we're going to be able to say that PS is congruent to QR. Opposite sides are congruent. That can lead to some nice equations, other things happening there. If I said that PQ was 2x plus 15 and SR was 3x minus 28, we could find x, we could find the length of the sides. The second rule of parallelograms is the opposite angles are congruent. Opposite angles are congruent. So in our parallelogram up here, in which we just mentioned that the opposite sides are congruent, our opposite angles are also congruent. So our angle P has to be congruent to angle R, and our angle S has to be congruent to angle Q. Opposite angles are congruent. Seems pretty simple so far, right? So we've recognized we're going to apply rules of angles and sides. So let's do one more. The consecutive angles of a parallelogram are supplementary. Everybody remembers what supplementary means, right? Equal 180 degrees. Everybody remembers what consecutive angles are. Really, technically, if we're looking at that diagram with that parallelogram, they are consecutive interior angles. Way throwback to our chapter 3 stuff, which means that they have to add up to 180 degrees. So I would say that angle P plus angle Q equals 180. I've actually got 4 sets that we could write in here. Let's just write in 2, just so that we can see them. So P plus Q, these 2 top angles up here have to be supplementary. Let's also say that angle S plus angle P have to equal 180. You could also write down, if you wanted to, angle S plus angle R equals 180. You could also add that angle Q plus angle R equals 180. So we really have 4 sets of consecutive angles because we have 2 pairs of parallel lines. So add those other guys in there if you like, or just make yourself a note. There'd be 4 sets of consecutive angles. And last but not least, we've got to talk about diagonals. Oh, we're not going to talk about diagonals yet. Hold on. If a parallelogram has 1 right angle, then it has 4 right angles. If a parallelogram has 1 right angle, then it has 4 right angles. So what we could say up in this diagram, again, I'm telling you that PQRS is a parallelogram. So I could say, well, if angle S equals 90 degrees, and you could fill in any one of them, then angle P equals 90 degrees, angle Q equals 90 degrees, and angle R equals 90 degrees. If one of those angles of a parallelogram is right, then all four of those angles are right. Again, they're consecutive interiors, so they have to add up to 180. So if S is 90, then any consecutive angle has to also be 90 because they have to add up to 180. So it all kind of makes sense if you think about it, and it'll make sense if you think about what you know a parallelogram is. So let's do a quick example, and then we'll talk about a couple rules. The other rules, then we'll finally get to diagonals. So if ABCD is a parallelogram, find A and B. I'm guessing you're going to tell me you want to find A first. Is our A information on sides or angles? So what do you know about those sides? What do you know about side AB and side DC? They have to be congruent, right? Because we've got ourselves a parallelogram. So if it's a parallelogram, opposite sides are congruent, which means that 2A equals 34, which means that A equals 17. Our B information is in angles. If I've got an angle A and an angle C, are A and C opposite angles, or are angle A and C consecutive angles? Because that's really where it comes down to. You know, we've been saying all along with these angle problems, they either add up to something or they're congruent. Well, are A and C congruent, or do they add up to 180? They're opposite angles, so they have to be congruent. Opposite angles. If they were consecutive, we make them add up to 180. So therefore, we can say that 8B equals 112. When you divide by 8, you get 1, 4, I think. Check my adding, or dividing, or other mathematical operations. So it's just using these 4 rules about parallelograms to set up equations. So let's do a quick talk about diagonals. So ABCD, our new example, is a parallelogram. So if ABCD is a parallelogram, you need to know that diagonals of a parallelogram bisect each other. Everybody remembers what bisect means, right? Bisect means cut into 2 congruent parts. 2 congruent parts. If both of those diagonals bisect each other, diagonal AC and diagonal BD are both bisected. So that means that AP is congruent to PC. That also means that DP is congruent to PB. The diagonals bisect each other, so you've got 2 congruent parts for each one of the diagonals. Now, we do not know if AP and DP are congruent. We only know from each individual diagonal that the 2 pieces are congruent. And last but not least, each diagonal separates a parallelogram into 2 congruent triangles. It's only going to make sense if we think back to our sides and side angle sides, because we know that we've got our reflexive side. So if I look at this diagonal, I know that triangle ABD is congruent to the other triangle DCB. So this top is congruent to this one. You just have to watch your congruent statement. I also know, if I look at the other diagonal, let me keep these 2 congruent guys together here. I also know if I look at the other diagonal that there's 2 congruent triangles formed. So I know that triangle ACD is congruent to triangle CAB. Opposite sides of a parallelogram are congruent, which means that we've got all kinds of corresponding sides along with that reflexive middle side. You can also use alternate interior angles. Because parallel lines cut by a transversal, you'd have alternate interiors. So an example, this angle would be congruent to that angle. So we've got all kinds of things that are kind of a throwback and yet kind of throwing into something new. All right, let's talk about a couple problems with this. Let's do 2 and 3. I think 2 and 3 are good ones. Actually, yeah. Number 2, I've got some Z information. And that Z information I noticed is on one of the diagonals. I should put in the directions that each one of these are parallelograms. Therefore, we can use our rules, any of those 6 things that we wrote in the table, which means that diagonals bisect each other. So I know that 3z minus 4 must be equal to z plus 5. I can easily solve this one and get a decimal for my answer. Number 3, I don't think we need to talk about the y, but let's talk about the x's for just a second. The x information is in angles. Are those angles opposite or consecutive? So will they be congruent or supplementary? So we know these are consecutive angles. Therefore, 4x plus 2x minus 6 has to equal 180. I don't think we need to solve it. I just want to make sure that you see what the setup's going to be. As far as the y's go, they're opposite sides, so we know that we can set them equal to each other. Opposite sides are congruent. If they were consecutive sides, we wouldn't have enough information unless there was something else given. So only angles you're allowed to do the consecutive part. I think maybe we should be, well, let's look at these. Let's look at just number 4. So we've got S's and T's and R's. So let's start with the R's. Here's a piece of R information. It's on a side. What's the only other thing that we definitely know that we can use? Well, the opposite side has to be congruent, right? So 4R equals 18. When you divide by 4, I believe you'd get a 4.5. S information. I've got S information here and here. The S information, it's not on an angle, it's not on a side. It is, however, on a diagonal. So we know that diagonals get bisected. So I know that those 2 pieces of the diagonal have to be congruent. So 8s equals 7s plus 3. Solve that one and you get a 3 for your s value. I'm hoping everybody thinks this seems really easy. The real reason that I wanted to talk about this one was for finding the t. Here's my t information here. That's the only piece of t information I've got. That last thing we talked about, the 2 congruent triangles, I've got a triangle like this, and I've got a triangle like this. If this is 2t, what has to be the CPCTC? What has to be the corresponding part of that congruent triangle? Or you could see it as an alternate interior. If these guys are parallel, you could see an alternate interior as well. This has to be congruent to that. Because they're alternate interior, they're also corresponding if we look at 2 congruent triangles. So 2t must be equal to 18, not to the 40, because that 40 is part of the same triangle. So when you divide, you should end up with a 9 for your value of t. So all kinds of sneaky ways we can throw some problems in there. So let's do one last. Let's look at this coordinate plane. So first of all, please sketch those 4 points. F is at -2, 4. G is at 3, 5. Make sure you label them. H is at 2, -3. And J is at -3, -4. It tells you in the directions that this is a parallelogram, so we can use any of those 6 rules that we had from before regarding angles, sides, and diagonals. But it does say determine the coordinates of the intersection of the diagonals. So in other words, if I drew in GJ and I drew in FH, I do not want you to guess where the intersection of those coordinates are, or those diagonals are. I want you to actually know. So think back to the 2 diagonal rules, or the 1 diagonal rule. Diagonals bisect each other, right? So this is congruent to this. And F to that intersection is congruent to H to the intersection. How could you find the actual coordinate of that point? Well, if these 2 pieces are congruent, either parts of those, that point right there is the midpoint of either diagonal. Aha, so now it makes sense why we did a quick review on midpoint. If we could find the midpoint of either FH or GJ, we would know what the coordinates of the intersection was. So I'll do FH, midpoint. So I'm going to add my x's from F and H, divide by 2. I'm going to add my my y values from F and H, 4 plus 3, plus negative 3. So I should have a 0, comma, 1/2. Over 0, up 1/2. How did your drawing do? Were you pretty close? If I found the midpoint of GJ, it would come out to the same thing. So there's kind of a built-in double check. If you wanted to make sure, you could double check by finding both midpoints and making sure that you get the same ordered pair for the midpoint of each. So that is it for section 6-2. So your homework's on page 407 and 408, 9 to 13 and 15 to 21. 21, I am looking for a graph, so make sure that you go back. Don't forget about test corrections. I know I'm not here today, but we'll check those tomorrow and go ahead and have time to work on them if you're interested. Tomorrow we'll talk about section 6-3. That is it. Have a great one. We'll see you tomorrow.